Here's our function g. Could you find the second derivative? Okay, so now I'm going to make your brain go back and forth. Integrate, derivative. No, that's not a word. Yeah. Derivative. So the first derivative. Well, this would be a chain rule. The derivative of sine is cos. Keep the inside the same, multiply by the derivative of the inside, so we get 10 cos 5x plus 3. And then our second derivative, again, the derivative of cos is negative sine. Chain rule again. So you get negative 50 sine 5x plus 3. Can you see that this is going to flip back and forth between sine and cos if you kept doing the derivative? And that with the 5 out in front, this is now 50. The next one will have another 5 out in front, which will be 250. So the front number will form a geometric sequence if you wanted to. So you could figure out what it would be the 500th derivative if you could figure out the pattern, if you wanted to. Write down the integral. If we integrate this, how do we integrate 2 sine 5x plus 3? What's the integral of sine? Negative cos. So we'd have negative 2 cos 5x plus 3. What do we do with the chain rule in this case? We have to divide by 5 plus c. Good. You're not paying attention? Okay.
I don't even like think like I know how to do it, but I just like copying you because it just feels like right.
Are we good? What kind of question is this one? A hard one? Because you tried it already and it didn't work? No. There's 3 numbers and they're 1, 2, and 3. It must be the easiest question in the world.
But it's also 1/2. That's like another number.
Okay, now that we've looked at it for a little bit, what kind of question is this? It's still difficult. Something chain rule. So what do we do? What do we call that with integration? Integration by substitution. So what are we going to let u equal? x3 minus 1. What is the derivative of that? 3x squared dx. Does that match with what we have in the question? But we can make it match by dividing by 3. Now we can rewrite our integral. Instead of the x squared dx, we can write 1/3 du. And we would have square root of u times 1/3 du, which is the same thing as 1/3 u to the half du. Integrating this, add 1 to the exponent, divide by your new exponent, plus c, multiply by the reciprocal, you get 2/9. Substitute back, which was x cubed minus 1, plus c. Not too bad. These are the harder integration by substitution because you have to work with the derivative a little bit to make it match. Now, if from 0 to 3 of f of x dx is equal to 8, this is just practicing your integration properties. One property of integrals is if there is a coefficient inside, you can pull that coefficient out. Well, since we know that the integral from 0 to 3 of f of x is 8, this just becomes 2 times 8, which is 16. For our second one, another property of integrals is that if you're adding two functions inside of an integral, you could take the integral of each one separately. Since we know the integral from 0 to 3 of f of x is 8, we just have to do 8 plus whatever this integral is, and the integral of 2 will be 2x, and you need to go from 0 to 3, so that will be, plug in 3 is 6, plug in 0 is 0, 8 plus 6, we'll get 14. Now, graphically, what happens to a function when you add 2? It moves up 2 units, right? So let's say I have some fun function between 0 and 3. Okay, and I take out my crayon and I color it in. Platinum dipped in mud. You have that. Now, if you moved it up 2, what would that do to that shape? Well, I'm going to actually, wow. I'm going to move that shape down here so we can play with it a little bit more. So here's our shape. And if I moved this part up 2, what would I get at the bottom? A new rectangle. And this length would be 2, right? And this length from 0 to 3 would be 3. The area of that rectangle would be 6. Does it make sense that we add 6 to the 8 that we already had? Okay? What is the integral of 2 from 0 to 3? If you graph y equals 2, what is that? A straight line. If you figure out the area between 0 and 3 of that straight line, well, it makes a rectangle. The height is 2. The length is 3. It makes sense that it's going to be 6. But we can use fancy integration to figure that out as well. So we can see why that is the answer. That we're just adding 2 to it, but the integration works that way as well. All right, so that's a little bit. Oh, no, we have one more fun one. What would happen if we did this? I'm going to steal the fancy graph that I had from before, get rid of the green, move that back down, steal this graph, and paste it. Okay. So now, what are we doing to this graph? We knew from 0 to 3 that that area is 8. What does f of x minus 2 do? Moves it 2 units to the right. So I'm going to take this curved, this colored part, and move it 2 units to the right. Originally, the area from 0 to 3 was 8. Now, what's it going to be from what to what? 2 to 5, because we just moved it 2 units to the right. So C is equal to 2, and D is equal to 5.